have done till lists, and today we will go first with tuple. I can say tuple, whatever. Okay. So, Python tuple.py. Okay. Okay. So first we will learn about tuples, and we will actually learn three things today mainly: tuples, sets, and dictionaries. And you will know that how we can convert them into each format. Okay. And unlike list that we studied yesterday, there are not so many functions that we can use in these types. Okay, because there are restrictions. Okay, for example, set only contains distinct items, so you cannot add the same thing again and again and count the number of items for same thing, because it will come one only. Okay. Dictionaries are unique because they have to be created in key value pairs. Okay, I'll show you. I'll make and show you how to do that. Okay, and dictionaries are basically used in making these management systems. For example, you are working somewhere, so the employee management system there, it will be made using the basic principles of dictionaries, or student management or college management system, like that. Okay, couples have a variety of applications. Okay, so let's go ahead, okay, and let's first start with tuples. Okay, so the difference between tuple and list. See, tuple is just the same as list with only one difference. It is tuple is unchangeable, which means once we put the items in a tuple, okay, you cannot modify them. Okay, make changes to them like we studied yesterday in a list. Okay, so if someone asks you what is a tuple, okay, I will give a short definition. Okay, tuple is a collection of items that are ordered and unchangeable. Okay, as simple as that, which means immutable. Okay, unchangeable. So you cannot change the things inside. Okay, and what and these two things are also the key characteristics of tuples: the ordered and also the index. Okay, so if someone asks you characteristics, okay, characteristics, you will tell them tuple is always ordered. Okay, I'll show you what that means. Okay, they basically maintain the order of items, and the second one is indexed. Okay, so you can access items in a tuple by referring to this index. Items are accessible using their or referring the indexes. Okay, so these are the characteristics. Now, how to, and yeah, also another one, of course, immutable. Okay, which means unchangeable. So tuples, unlike lists, always mention this. Okay, cannot be changed once created. Okay, I'll show now using practicals uh, how we do that. But yes, you might ask that why we use tuples. Okay, now I have shown you how versatile the functions of lists are. You can change, remove, modify lists in so many types. And also, lists are used to make data frames. So when we do data analysis or machine learning, we use lists a lot. Okay, a lot. So people might ask, what is the purpose of tuples? Why use tuples? Okay, you must always be clear with the fact of why. Okay, okay. So why use tuples? So there are also 3 points. Okay, first, it is faster than lists. Okay, now why is it considered faster than lists? Because as we know, lists may or may not be ordered, but tuples are always ordered. For example, when So for example, there is a tuple of from 10 to 100, okay, and I directly uh, access this particular element, you will know the position always. But that is not happening in list, right? If you are going to search in a list, you first have to sort it in a proper order, and then you have to find it. Okay, so in that way, it is faster than lists. Okay. Second is, it is a fixed collection, so you cannot make changes. Like for example, you cannot corrupt the values, the data stored in tuples. Okay, so it is, for example, you know, the days of the week. Okay, or for example, user access labels. For example, you have made a software, for example, okay, and the college management software, for example, that I just mentioned few minutes back. So there you will have access of various levels. The principal or the dean, that person will have a super admin kind of access. Okay. Then the professors, associate professors, the teachers, basically the educators, they will have access only till their level, where they will only be able to upload courses and teach, and mark the attendance of students. Okay, add materials and stuff. Okay, and the students, they will only have access to their level, where they can just see that, yeah, their attendance is marked, they have got the materials, and yeah, here are the courses that they can view later. Okay, so these cannot be corrupted later, okay, for example, by any external factor anyhow, because that is the function of tuples. They are always fixed. You cannot remove by any chance a particular thing, okay, and crash the whole system or something. Another thing, since it's faster, it has fixed collection, you cannot corrupt it, and all those things. The most common thing that comes is memory efficient. It takes up less memory compared to lists. Okay. Now let's n- learn how to create a tuple. Okay. You can call it tuple or tuple, whatever the concept. Okay. So here, when we used to create a list, we always used to use the square brackets, right? 10, 20, and 29, 20, 30, whatever. Okay, but in a tuple, you don't need that. You just simply give the input. You can either write like this in a tuple. Okay, in fact, yeah, you can also add this. So, for example, add a string. Okay, no issue at all. And you can also write it as, okay, if you want, you can just use a first bracket and write. Okay, no difference. Both are same. Both of them mean the same thing. Okay, so if I'm printing, okay, for example, um A comma B comma C. Let's see. यार ये इनवैलिड, अच्छा टर्मिनल चेंज नहीं किया मैंने. न्यू टर्मिनल विंडो. Delete all the terminals. Yeah, right. Save it. Now run. See. So, three of them are printed, right? As last time, actually, I forgot to delete the last terminal, and that creates error because it's local device. So, and local device always works on cache. So, if you don't delete the last terminal, okay, the same data, it will overlap, and that will create issues. Okay, so always remember to delete your last terminal. For okay, yeah. So now, for example, if I print type, okay, of A, copy B, add V, sorry, C, save, and see. First one is list, as I told. The next two, as I said, with or without parentheses, you can both write a tuple, and yeah, obviously they are class tuple. Okay. So now, how to access the tuple items? Okay. So in order to access, it's simple as yesterday. You can do it. For example, tuple V, and I want to access the second. Okay, it will give me 30. So it is 0, 1, 2. So it gives me 30. Okay. Then this was about accessing. Then comes tuple functions. Okay. Not tuple functions. There are not a lot of functions. It's like only length of the entire tuple, count, the index, and slicing. So mainly four types. That's all about tuples only. Okay. I am showing you how to do that. For example, print len. Okay. Let me get the heading. Yeah. So len. Okay. So how we do it using len function, right? Len b, and it will give me the length 4, 0, 1, 2, 3. Total 4 items are here, so the length is 4. That's it. Okay. Then count. Got it? So count, how we do it? Simply print b dot count, just like we did in list yesterday. For example, how many number of an item is there? For example, I write 10. Okay, and I run only once. Okay, any item, because you cannot add items to a tuple. That will create error. Okay. Then comes index. Okay, which means it returns the index of the first occurrence of specified item. So print a dot index, and let's say I want to access PVC. Okay, this will create an error. But because there is no TVC in A, it's in B. It's my fault, obviously. Save. It's in the third position. 0, 1, 0, 1, 2, 3. Okay. This is the third position is there. Okay. So yeah, it gives the position of TVC. Okay. Then finally, it's a slicing. So slicing is an important concept which and will be used a lot in the applications. Further applications we'll be doing. So what is slicing? We can basically extract a part of the tuple. Okay, using slicing. So, for example, in the college management system that I just referred, for example, there are branches of physics honors student, chemistry honors student, life science students honors, then computer science students, and you want to extract only a particular set of it. Okay, for example, you want to uh, extract the data of only the life science students. So there you can do slicing, because in tuples you can do nested tuples that I'll show you next. Okay, where you can add multiple tuples inside a tuple. Got it? Let me show you how. Print b, okay, then 1 colon 3. I'll explain you the meaning of this. Okay, this, let me write inside in the bracket. It basically means start dot colon end, which means it extracts items from the start index. Okay, but it does not include the end index. Okay, yeah, 20, 30. So it starts from first position. Okay, but it does not include this index 3. It starts with index 1 but does not include the index 3. Similarly, if you write here 2, okay, then it will give only 20, because in the index 2 we have 30, which we have excluded in the end part, and we have used index 1, so which is 20 here. Okay, so if you want to make a tweak, for example 0, okay, if you make a tweak 0, it is 10 and 20. So we start from 10, we go till 20, we exclude 30, which means we take index 0 and 1 and we exclude index 2. So that is a concept of slicing. Okay. Now, as I said about the college management software, So for example, I told about nested tuple, right? So for example, nested tuple, I'll show you slicing. Okay, that way. For example, I just name a variable tuple. Okay, equals to say inside I'll add three tuples. For example, okay, students' names. Okay, for example, physics student. There's someone called for example, Arun, okay, Rohan, give me some names. Karan. Okay, this is one tuple inside. Okay, now this whole tuple is taking index 0 here. Okay, next we go for another tuple. Okay, let's say Abhi, Gurpreet, say Tanveer. Got it. Okay, and this is another tuple. Okay, this takes the index 1, and now we will go to another tuple where we add names of, like for example, the licensed students. We can actually assign these values, and I will show you next in the dictionary how we can assign the values to them, like who which students are part of which set. Okay, I'll show you. Let's say name as oh, my name, I'll add your guys name, Vijit. Then yes, Manishan's here. My name is here. Okay, so this takes the index 2, and now I want to slice it. Okay, so I do print. Okay, and I write nested tuple. Then I write square bracket. I start from 0. I go till 2. Okay, so I'll exclude 2 and I will start from 0. It's an error. Okay, sorry. We don't do it like this. What we will do is we'll take 2 only. Okay. Uh, yeah. So it will directly give you the value in the second. Okay. We here we don't exclude like that in case of nested tuple. Okay. We only just give the index. Okay, so this is how we handle mixed data types. So this was our tuples. It is pretty easy actually. Okay, and we use, and until and unless you are doing something, development stuff, we don't use tuple as much. We if we are doing something data related stuff, we use either dictionaries or lists. Okay, but yeah, application may demand. Okay, if somewhere we need to use tuples, we will use tuples. Okay, there's a hard and fast rule. So till now, you guys have any problem? Then we will go to sets and dictionaries. Okay, any problem? Any doubt here? Any part I need to repeat?
Can you repeat the nested tuple once again, please?
Sure. Okay. So the nested tuple is basically inside one tuple, you can create multiple tuples. Okay. So for example, straight. Yeah. So for example, you are forming a system, okay, where you have in each system, in each category, for example, you have subcategories. So in that case, you can use the application of nested tuple. Okay. For example, you are playing a game with people. Okay, and there you're pairing up. Okay, so you can do, see, in that game you will take the entire number of students or number of people as one set, of course. Inside, when you are making subsets like that, okay, then there you can add people in groups, okay, and perform several activities. Okay, so for that we use the nested tuple, and in its and it the use is the same as others, as alien, count, index, or whatever. Okay, so this is mainly used for handling the mixed data types. So for example, if I make like this, wait, for example, I may take D and uh, for example, 10, 20, 40, 50. Okay, uh, code for example. Okay, so here, give me a minute. Yeah. So now, if you want to print, of course, it will print this tuple. Okay, inside, I'll just add another tuple. Okay, for example, 1, 2, and 3. Okay. Now here are mixed data types here, of course. Now we will, in order to access them, what we will do, 2, 1. What is happening? I'll tell you. It's giving an error. Why? Okay, okay. 2, 1. Okay, sorry. 2, 1. Basically, the index 2 here, the position 2 is taken by 61. Inside, we don't have anything. Okay, that's why it's showing error. The point is control. If you put it here, okay. For example, we have something at the second position, and we have a nested tuple, okay, in the third position basically, so index 2, and there we want to access a particular element inside this. Okay, then we can use this. Yeah, so here you have, in the second position we have 2. Okay, let me explain this again to you. See, index 2, which means 0, 40, 1, 50, and in 2 it's here. Okay, now here I want to access the element at index 1, which means inside this again it is taking 0. There's a 1 and this 2, so it will print 2. I'll run this. See, it will print here 2. Similarly, in the above case, in this nested tuple, for example, if I do here, for example, second one, here it is taking one whole index, the 0 index, this is 1 index, and finally this is the second, the index 2. Okay, now here I want to, for example, access the name of Manisha here. So for example, I'll just write here 2 again. Okay, I'll save. So it will give me Manisha. So if you have multiple subgroups under one big group, and you don't know how to access a particular element, then you can use this nested tuple concept. Are you clear now, or I'll explain
Yes.
again? Okay, fine. Okay, chalo. So then tuple is clear. Others, you have any doubt, you can interrupt and ask. Okay, next we will go for sets. Now sets are a bit tricky thing. Okay, not so tricky. Basically, it's you cannot set of functions a bit different that we can use here. Okay, we all have learned sets in mathematics, so it is not different to that. Okay, it is just like collection of items, and it's similar to list again. And also it contain items of the same type, such as all integers or mix of different types like integers and strings. Okay, so sets like lists. Okay, they are collection. Is a collection. It's a collection of items. Okay, and it is and it uh, contains items of the same type, such as all integers or a mix of the same type. Okay, like mix of same type or like or different types also. For example, such as all integers. I want to say different types. Okay, different types like integers and strings. Okay, now but there are some key differences between lists and sets. So which are first, they are all distinct items, which means when we make lists, we can add one name multiple times. Okay, and we can count how many times they are repeated. Okay, but in set, you cannot add one thing repeatedly. For example, already one name is, for example, the name Rohan is already there in the set. Okay, you cannot add another Rohan. Okay, that is so it only contains unique items. Okay, a set contains only unique items. Okay, always remember this. Then next is unordered. Okay, so sets do not maintain any particular particular order of items. Okay, so if you add in a specific order and then print the set, the items may appear in different order. Okay, when we will do, you will see right now. And then no indexing. So unlike lists, no indexing, which means sets do not support indexing. Cool. So you cannot access a person cannot access items by their position in the set. Got it? So from this, it is clear that set cannot be used for making systems and software part. That's why it is because you cannot index, you cannot get access to a particular thing. Okay, and of course it is again unordered, so that's a problem. And if it is containing only distinct items, we may need one thing several times in a system. So in that time, this feature is not at all helpful. So again the application of list is overpowering the application of set. Okay, but again, why sets then? Why are we even using it? Why use sets if list is doing all the tasks, making life easier? Why sets? Then we say we have fast operations. Okay, for example, operations like union. Okay, like we want to unite two different sets. Okay, we want to find the common between them. These things again are not possible in a list. Okay, and these are mathematical things. Okay, so these are only helpful by using a set. Okay, then another thing, hashing. What do you mean by hashing? So they use hashing which allows for fast search, insert, and delete operations. Okay. So That basically helps in CRUD operations a bit. Okay, allows for fast search, insert, and delete ops. Okay, so now this was all the theory of sets. Let's jump to practical. Give me a minute. Okay, so first topic is how to create a set. Okay, simple. For example, we just give a name. Here we use this second bracket. Okay, and just simply write three things. Print it. Okay. Now, let's delete this terminal against or else it will create problem. Yeah. So it prints it, but what data type it is? Let's say we print type of it. Okay. Sorry. To this. We run it. Classifies as class A set. Sorry. So this is how we create a set. Okay. There are some other methods also. For example, if you have a list, for example, B is equal to 10, 20, 30. Okay. But now you want to create a set out of it. Like, as I said, it allows for fast search, insert, that union operations. But you might ask, if we are working with data, okay, and we need a list to make a data frame, okay. But here we need the operations of the union. We need to find the common factors. We need to find the differences. We need to find the intersection, okay. What will we do? We need sets, right? So basically, there has to be a way to use set. So simply, what we do here, we write set and just use a brackets. Got it? Then print it. Let's say you will also print the type here. Okay, that way you'll understand which also data type it is. Print B. See it. Yeah, I gave the input in square brackets, which was actually a list. But when I use the set parameter, okay, the set function, and then I ask that what is the type that I am creating, the data type. It gives us class set. Okay. So these are how you can also convert a list into a set for a particular, operation need. Lastly, you might want to create an empty set. Okay. Can be various needs, whatever. Okay. Control S. And this is, it will just give this. This is basically an empty set. Okay. And yeah, in order to create an empty set, you cannot write this. Okay, this is basically a diction. Then it becomes a dictionary actually. Okay. But if you want to create an empty set, you have to use this function so that it will give a set. Okay, I'll teach you dictionaries in few moments. Okay. Now let's do some. Now again, as I told, tuples were immutable. You cannot change it. Here in the set, you can change and remove things, right? So let's do some of these functions and understand what's it like. First, we will do add. Okay, so it basically adds a single item to the set, and it already exists. The set remains unchanged. Okay. For example, we have made some sets here, right? Let's say I'll add to A equals to, sorry, okay, A dot add. Okay, and here we add another value for 56, and now I print A. Yeah. So it has added 56. But yeah, again, since it's unordered, it may put 56 anywhere, anytime. Okay. So that is so that way you have to sort the things. Okay. You can also update. And now let's remove. Oh, see, these are all very simple things, small things. You don't need like a very lot of, you don't need a lot of logic to understand this, because Python is the easiest language and the applications are very easy. Okay, that's why people use machine learning, AI, and data analysis. We use Python. Python is preferable. R is also preferable. R is simpler than Python, but because Python has such huge libraries and frameworks, okay, that's why we definitely we usually go for Python. But R is also developing, evolving with each day. So you will see in research, if when you're working with PhD scholars or postdocs, most of when I used to work with them, I saw most of them used to work with R, but they never made a hard and fast rule like that. I use R only because I'm working with R. They said you can use Python also, or some of them said you can use MATLAB also. Okay, you just have to get the things done. Okay, so you can do anything. And since Python has so many, inbuilt functions, so many keywords, it actually helps you to get your things done here. Okay, and as fast as possible. Okay, in if you are coding in Java or C++, in order to do this simple thing, you have to write like these means these many lines of code just to add 56 to this point. Okay, so that's the problem there. In fact, in order to just print hello world, you will have to write so many lines. But in Python, it is not like that. Okay, now let's learn removing elements. Now here we add do have some multiple functions. Okay, removing elements from a set. Okay, we use discard function, we use remove function, we use clear function. Okay, so first I will go for a it's already made. So what I will do, a dot discard. Okay, and let's see, I'll just remove 56 only that I have right now. Print a, see, it has removed 56 now. Okay, now another is clear. Okay, or say remove. Okay, for example, s dot remove. For example, a dot remove brackets. For example, what say did I make? 10, 20, 30, right? Okay. So I'll just remove here 20. And wait. A. So we are now left with 10 and 30. Again, we have another function, clear. See, now clear is used to completely eradicate the set. Like it will give an empty set in return. Okay. See, it gives an empty set because it eradicates all the doesn't mean no matter the number of elements inside, it will just clear all. Okay, okay. So let's go to the other set operations. Okay, here we will do the. Okay, let me just show you meanwhile. Okay, I'll show you the first the length. Okay, and in I already have a function made. So let's say print len a 0 because I have already cleared it. Okay, no items are there, but yeah, if I just move it and now print ln there, it has two items inside. Okay, and if I just remove this only. Okay, oops, save. Now it will have all the items. So yeah, all the three items are here. Okay. Anyways, yeah. Skip it as it is. Okay. I need to. I'll now take set B because I have completely eradicated set A. Okay. Let's go for set B now. Okay. Let's remove this print thing. What's this? Save. Okay. I have already transformed this into a set. So you can also check if a particular element is inside or not. For example, what are the elements here? 20, right? So let's say 20 in B. Now it will give you output in either true or false. Okay. True means it is there, and false means of it's not there. True, it's there. So if you are doing like 45, it's not there. Okay. So in this way, you can check it gives false, which means of course it's not there. So here you can see, but when it's large, it's a very large set. Okay. And you have to search a particular thing. You're not sure. You will, there are 10,000 elements inside, 10,000 items inside. You're not going to sit and manually check whether it is there or not, right? You will just simply give the code key whether this item is there or not, this and this, and it will give you true or false. If it is not there, you will add it, done. If it is there and you don't want it there, you will remove it, discard it. Okay, so that's what it is. Now after this, the main game of sets. Why we use sets basically? For the union, intersection, and difference functions. Okay, so there are functions for it. Okay, but we use symbols here, right? For example, now I will make two sets. Let's say S equals 2. Okay, just add 1, 2, 3, 4, 5, 6, 7. Sorry, 7, 8, 9. Okay, another set I add as S1. I give 4, 6, 2, 8. Got it? Now, first, okay, let's say I'll add some more things, right? For example, 30, 30, 25, 7, 78. Okay, you will understand why I'm doing this. So here, okay, another is here difference and symmetric difference. Okay, uh, difference and symmetric difference because that is also important here. Okay, so and another is you can also check these are set or not. Okay, so let's start. We will check. Okay, that we'll check later, but first we will do these functions. Okay, so print S for union. We use this symbol S1. Okay, control save it. We run it. See, this will give everything, and yeah, this does not repeat the numbers already. There were already 4, 2, C, 7, 8, something. There were some repetitions, so that will not repeat here. Okay. Uh, I'll just write inside union. Cool. Then we go for print intersection. Okay. S S intersection S1. Okay. Uh, See, it gives the intersection. Okay. Means whatever was there in S1, it was actually in S. So yeah, it will give an intersection. Basically, it's a subset that this basically also is a subset of S1. Yeah, S1 these items. Okay, if we take it separately, got it. I'll write here intersection. The total thing is not the subset, only that part. Okay. Now the difference, which is print S minus S1. So save. Only the items, okay, it excludes the common items in S1 and only gives the rest of it. Okay, so this is the difference. Okay, and finally, we go for symmetric difference. It returns elements present in either set but not in both. Print yes. For symmetric difference, we use this symmetric difference. Control S. See, it removes the items and gives the rest. So this is the symmetric difference. Now we go for the subset and superset operations. Okay, another important aspect of using sets. Subset and superset operations, right? So here we go for disjoint, subset, proper subset, superset, and proper superset. Okay, and again we use symbols only. Okay, so for example, we use print s1 dot is disjoint of s. Okay, I save it. It will and these and the output here you will all get in true or false boolean. Why? Because here we are checking whether the condition that we are giving is correct or not. Okay, so false. It is not so it is not disjoint. Okay, so it returns true if the two sets have no elements in common. Got it? Then print. We will go for subset. Okay, so here s1 for example is so this is the subset symbol. Got it? Okay, this is a disjoint. This is a subset. Okay, false. It is not a subset. Okay, print. Now we will go for superset or say proper. Let's take a proper subset. Okay. Mm. Hmm. Again, false. It is not a proper subset. You can meanwhile you guys make your own sets. Okay, and check this whether you're getting how you're getting it true or false. Okay, I'll give you some specific questions on data types only. Okay, by tonight, some 20-30 questions you can, solve. Try to solve them. Those will be very basic questions, and it will be completely based on what I am, you know, teaching you. Nothing out of it. Okay. Also, you'll get the recording. Yeah. So then superset. So in order to check the superset, S S1. Okay, it is not superset because there are different elements. Of course, we know that. Okay. False. It is not superset. We know already. Okay. Now then we'll print proper superset. Okay. S1 proper superset. Okay. False. All these are false. Only reason is because here are some different distinct elements. What if we just remove them? Okay. Let's just say we are removing these elements. Okay. Control S. Now let's see the difference in the results. See. Now it's all true except that the disjoint is false. Also the answers here are different now. Okay, so only for that it was coming false. Okay, now if you change it, for example this thing, just write s1 instead of s instead of s1, you will get a different result. Okay, so that is all about sets.